Alright, here we are at the answer key for practice test number 2. Hopefully this will work out well. We are looking at a graph of a quadratic. Because it's x squared, it has been translated 1 to the right and down 1, 2, 3. Quadratics open upward, but it's got a scaling point that's 2 times. So I can just plug in 0 if I want. That's an easy one. And when I plug in 0, I get 1. When I square a negative 1, 1 times 2 is 2. 2 plus a negative 3 is negative 1. So it goes up through there. And of course, with the parabola, you get that symmetry. So I've got really 2 points. And so it says clearly label at least 2 other points. That y-intercept is an easy one. Another easy way to think of it is if you go over 1, you're going to go up or down that amount. If that's a negative 2, you'd go down. If I go over 1, I'm going up 2 units. So there it is, 2 comma negative 1. And the vertex, it wouldn't hurt to label that, especially if I ask for it. The vertex then is 1 comma negative 3. Alright, this second one then is a logarithmic function. Again, the parent logarithmic function goes like that, and it goes through 0 comma 1 and 1 comma 10. So that's a good thing to bear in mind with a horizontal asymptote there of y equals 0. What's happened now is I've translated it 4 units to the right. Actually, best to look at the flipping first. I apologize. That is flipped upside down, and so these are mirror images now, flipped down, and then it's been translated 4 to the right and 2 more down. So this point here goes 1, 2, 3, 4 to the right, and then down 2 more. So that is that point. The y equals 0 asymptote has been translated down, and then that other point is going to be way down there, and I'm just going to fake it and draw it going off the page almost, and you can just label it as long as you've got that other point. What was 1 comma 10 has now been flipped to 1 comma negative 10, and then it's gone 2 more. So that's going to be 1 more over from positive 4 to positive 5, and then negative 12. Okay, once again, just be clear on that. In our original function, it's at 0, 1. So when I go from 0 over to 1, it goes up 10. Now when I go from positive 4 over 1 to 5, I'm going down 10 from there, or down 9 more from negative 3 to negative 12, because it's going up from 1 to 10, which is a change of 9. It's going down 9 from negative 3 to negative 12. Alright, so there are the 2 points, 4 comma negative 3 and 5 comma negative 12. Alright, next page. The computer doesn't print out the arrowheads. I hope it's clear that this, for instance, is going on forever, starting at that point. This goes hugging that asymptote, and this goes down. At any rate, coming back to this first one, this is, I hope, clearly a cubic. Y equals x to the third. And it looks like it's been flipped and shifted. So we're going to start with y equals. Now, I could think of it flipping this way, or I could think of flipping it this way. It's the only one where it doesn't make any difference which way you put that negative sign. I'm going to say it's a times negative x to the third. Yeah, and then we're going to translate it, I guess. So let's say y equals a times, and then negative, and then it's shifted over 2, so it's x minus 2, close parentheses, to the third, and then minus 1. Alright? So I put the negative sign in. You could just as easily take it out, but I've done it this way. When you go to substitute in this point here, which is 0 comma 1, to solve for a, we'll work through and very carefully and get a. So I plug in 1 for y. 1 equals a times negative, and then 0 minus 2, close parentheses, to the third, minus 1. Alright, well, 0 minus 2 and then negative makes that positive 2 to the third. So I get 1 equals a times 8 minus 1. If I add 1 to both sides, I then get 2 equals 8a, so 2 over 8 equals a equals 1/4. So then y equals 1/4 minus x minus 2, close parentheses to the third, minus 1. That should be my correct formula. Let's plug it in just to make sure. If I plug in 0, 0 minus 2 is negative 2, made positive, that's 8. 1/4 of 8 is 2. 2 minus 1 is positive 1. You could try for another point. It looks like it's going to be very close to negative 3 and positive 4, negative 3. If I plug in positive 4, I get 2, and I have the negative sign there, so when I square that I'll get negative 8, and multiply that times 1/4 gives me negative 2, minus 1 gives me negative 3, so that also checks out. The next one then looks like it's a root function, y equals radical x. It looks like if it normally starts here and goes like that, it's been flipped both places, so I'm going to start with the flips. Y equals minus and then a, radical minus and then my x. In this case it's moved over 5, so I'm going to do x minus 5, and then it looks like it's been raised up 1, so plus 1. Okay, again that point there is at 5 comma 1, negative 5 and plus 1. Now I'm going to put in my other point here, which looks like it is negative 4 comma negative 2. You have to count carefully, but that's negative 4 and that's negative 2. And so I'm going to substitute that in. Negative 2 equals negative a, radical minus, and then minus 4 minus 5 plus 1. So the minuses throw people off sometimes because it's under a square root, but negative 4 minus 5 is negative 9. Negative 9 is positive 9. The square root of positive 9 is 3. So I get negative 2 equals negative 3a plus 1. Well, if I solve for that, that gives me a then is a positive 1. So that's pretty simple. A is just a positive 1, so there's no other change there. It's just y equals negative radical minus sign x minus 5 then plus 1. Okay, so that's that answer. Finally, looking at this one, this is an exponential. We know it's exponential because the horizontal is the asymptote. Even though this is steep, it's clearly not straight vertical, whereas that is about as horizontal as you can get. So that parent function then is one where it goes over and then zooms up. And what's happened is that this has been reflected to go down and then reflected to go backwards. So it's been double reflected, just like the radical, just like the square root of x function. So I'm going to start off with y equals and then negative 10 and then to the negative and then my x value up there. Okay, and then I'm going to translate it. It looks like we normally have that point that's 0, 1, and if we flipped it down below and upside down, it would be down here at 0, negative 1, and that's been moved up, let's see, up 2 places to go to positive 1. So, but that, I'm talking about the x value is at 0, and it's moved over 3 units. Sorry, the x direction has been moved 3 units. So y equals minus 10, and then negative, and then it's x minus 3, shifts it 3 to the plus, and then it's moved it up 2 notches, so up 2. Again, because the original belly button point would have been at negative 1, now it's at positive 1, it's up 2. The original x would have been at 0, and now it's at 3, so it's shifted 3. And so that is that final function. We have not gotten an adjustment there. There won't be one on the test with an a value up there. You can double check by plugging in this point to see. If I plug in -2 for x, okay, there's not a problem. Alright, so plugging this in, oops, that should be +2. That will be corrected before I post it. That's a +2, -8. If I plug in +2, -3 gives me a -1. -1 is a +1. 10 to the 1 is 10, so that's -10. So y equals -10 plus 2 equals -8, and that is what is right there. So that checks out. So there are the three equations for that page. On to the last page here.